Hello everyone, in this video we're going to learn about compound probability. First we're going to talk about the independent probability. With independent probability, the first event does not impact the outcome of the second event. So probability of A and B equals probability of A times probability of B. Probability of A equals the number of A options divided by total possible outcomes. Probability of B equals the number of B options divided by total possible outcomes. The keywords for independent probability is replacement. Alright. Next one, we're going to talk about the dependent probability. With dependent probability, the first event impacts the outcome of the second event. Probability of A and B equals probability of A times probability of B. Alright, probability of A equals the number of A options divided by total possible outcomes times probability of B. Probability of B equals the number of B options after choosing A divided by total possible outcomes after choosing A, which means you need to exclude A. Alright, so let's take a look at the first example right here. If you dealt 2 cards successively from a standard 52 card deck, find the probability of getting a face card on the first card and an ace card on the second if A with replacement on the first one. So the keyword right here, replacement, we're going to use the first formula right here. And B without replacement on the first one, we use the second formula right here. Alright, now first we need to understand what is the face card. Alright, face card, we have 12 face card right here, which is this guy. Alright, we have 4 jack, 4 queens, 4 kings, and ace card. We have 4 ace card right here. Alright, question A. So we have probability of face card and ace card equals. Now first we're gonna pick face card. So we have 12 face card right here. So we need to pick one face card, but we have 12 options. So it's gonna be 12 over the total right here. Right, we have 52 cards. So 12 over 52 cards. Alright, multiply by, for example, I pick this guy out. After I pick this guy out, I need to put this guy back. So the total possible outcome still the same. It's still 52 right here. Now, the top right here, I need to pick an ace card. So I have 4 ace right here. This guy. So it could be 4 over 52. Now I need to simplify this one. So it's going to be 12 over 52. Divide the top and bottom by 4. So it could be 3 over 13. Times divide the top and bottom by 4. It's going to be 1 over 13. And when you multiply this guy, it should be 3 over 169. And this is the answer for question A. Alright, let's move on to question B. Now the keywords right here, without replacement. So we need to use the second formula right here. Alright, so probability of face card and an ace card equals. Now, face card, we have 12 options to pick a face card. So it could be 12 over 52. For example, I pick this guy out. So when I pick this guy out, I don't put it back. So this guy gone. Alright, I only have 52 left. So for the second one right here, this should be 52. Alright, Now I have 4 ace card right here, so it should be 4. Now I need to simplify this one. It should be 3 over 13 times 4 over 51. And it's gonna be, alright, so 13 times 51. It's gonna be 63, so the top 3 times 4 it could be 12. 12 over 663. Now we need to simplify. Divide the top and bottom by 3. So it should be 4 over 221. And this is the answer for question B. Alright, let's move on to the next one. Probability of mutually exclusive events. Alright, so if event A and event B are mutually exclusive events, then probability of A and B must be equals 0. Alright, so which means A and B have nothing in common. So probability of A or B equals probability of A plus probability of B. Now, probability of overlapping events, which is non-mutually. If event A and event B are overlapping events, then probability of A and B must be different from 0. Alright, so probability of A or B equals probability of A plus probability of B, and then you need to subtract the overlapping one right here. So probability of A and B. Alright, so let's take a look at example number 14 and 15. Student athletes at a local high school may participate in only one sport each season. What is the probability that a randomly selected student athlete plays volleyball or is on the swim team? Alright, so volleyball, we look at the volleyball right here. This guy right here, which is 10%. Alright, and then the swim team right here, which is 24%. So since event A and event B have nothing in common, so this is called mutually exclusive events. So probability of volleyball or swim team equals 10% plus 24%, and it's gonna be 34%. Alright, now let's move on to example number 15. Finding the probability of non-mutually exclusive events. What is the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? So look at this one. This is a standard number cube which has 6 faces, number from 1 to 6. Alright, so probability of even numbers or multiple of 3 equals probability of even numbers plus probability of multiple of 3. Subtract probability of even and multiple. Alright, so we just substitute value now. Probability of even number. So we have 3 even numbers, which are 2, 4 and 6. So it can be 3 out of 6. Now, multiple of 3. We have number 3 and number 6. So which are 2 over 6. Now we need to subtract even and multiple of 3, which is only number 6. So 1 over 6. So the answer must be 4 over 6 or 2/3. And this is the answer. Now let's check for your understanding by doing this problem right here. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.